Hi everybody. So this next section that we're going to look at is 3.9 on inverse trig functions and their derivatives. So let's review the inverse trig functions here first. So you might recall that the inverse trig functions look like this. Again, remember they're what you get basically when you flip the original trig function around that line y equals x. The only thing to keep in mind again is that, remember, trig functions are not one-to-one. So you have to have some sort of restriction on the domain in order to make to find the inverse. So remember that there is sort of a restriction on the domain and range, in particular the range values for these functions, right? And those are kind of arbitrary. So those are things you should just have memorized, or know what the graph looks like, or put that on your formula sheet. So just remember that the especially like for the inverse tangent function, right? The the range is between negative pi halves and pi halves. For inverse cotangent, right, it's between 0 and pi. Right? In particular, I guess that's one set of trig functions that you'd want to look at. So just be careful that the range values always fall in there, right? So for various values of x, right, you'll see that they'll all fall between those values, right? Let's maybe just practice using reference angles to find the various angles here. So let's say you want to find cosecant inverse of, say, square root of 2, right? So, I guess one way of saying that is you're saying cosecant of the angle is equal to the square root of 2, right? So you could think about, well, what angle would give you square root of 2 in that case, right? Now remember that, cosecant is the same thing as 1 over sine. So you could think of that as being the trig function that would give you, I guess, sine of theta is equal to 1 over the square root of 2. And if you think about that, right, that would be pi fourths. Right? Similarly, right, I guess you could think of this as the sine function that would give you negative square root of 3 over 2. Right, remember the angle again has to be between, for the cosecant function, right, remember the angle has to be between negative pi halves and pi halves. So although you might think of it as being something greater than pi halves, right, you should really have a negative value there. Or for something like this, right, you could think of this as sine of theta is equal to 1 over 2, right? That would give you a value of pi sixth. So let's look at derivatives of the inverse trig functions. And I'm not necessarily going to go through the derivative of all of these, but we will go through the first one here. These will largely just be things you have to have memorized or put on your formula sheet, but just to talk about how you can derive these if you want to. What we're basically going to do is use the inverse, the derivative of the inverse function that we talked about in the previous section, namely the fact that the derivative of the inverse is 1 over the derivative of the original function evaluated at the inverse, right? So the original function in this case that we're talking about is sine, right? So we've got, right, because we're trying to find the derivative of inverse sine. So the derivative of sine, remember, is cosine. You evaluate that at the inside function. Now, what we're going to do is use some trigonometric identities to simplify this, right? Namely, the fact that cosine of u or cosine of x or whatever is equal to the square root of 1 minus sine squared x, right? That's the Pythagorean identity there. And then just remember that sine and sine inverse, they will cancel each other out, just leaving you with an x squared there, right? And so that gives you the derivative, right, if you want to derive those from scratch. Similarly, if you look at the proof of the derivative of cosine inverse, again, using the same rules here, I've just written this a little bit differently in chain rule form, right? You get the same you get the result, right? So I mean, I guess these derivatives aren't the same, right? They're pretty close. And remember, this is written in the chain rule form, right? So du dx would be 1 in that case. So here the derivatives are pretty similar. Right here, I guess you've got a minus for the cosine, and for the sine you don't, right? Similarly, the derivative of inverse tangent can be given by this, which again is the same theorem that we used before, theorem 3. That gives you 1 over 1 plus x squared. Couple things to note here is the derivative of the secant inverse curve should always be positive. And here's the derivative of the inverse secant function. Again, I'm not going to bother going over the derivative, the derivation of this. Again, if you write this without the chain rule, right, it would be written like that, because the derivative of x with respect to x would just be 1. So that's another way of writing that. Couple things to keep in mind is some identities, like the inverse cofunction identities. These relate sort of the inverse sine and cosine, etc., with one another, so they're kind of like the identities you've seen before. So here's just a list of all the derivatives, again written in the chain rule form. So again, you basically just need to copy these down or memorize these and put these on your formula sheet. So that's really all that's new in this section. So let's maybe practice using some of these formulas with various other rules. Let's say I want to find the derivative of cosine inverse of 3x squared, right? Well, what's the derivative of cosine inverse? That would be negative 1 over the square root of 1 minus x squared. But I want to replace the x with 3x squared, and then by the chain rule I have to take it times the derivative of 3x squared, which is 6x, right? Let's say I want to take the derivative of sine of cosine inverse. Well, the derivative of sine is cosine. Evaluate that at the inside function times the derivative of cosine. I realized I just forgot an x here. Sorry about that. And then what's the derivative of cosine inverse? Right. Well, we just looked at that. Right. Derivative of cosine inverse is negative 1 over the square root of 1 minus x squared. Right. And then you can go ahead and do whatever you want to simplify that, I guess, or whatever is necessary. Here the cosine and cosine inverse will cancel, just leaving you with an x. Let's say you want to take the derivative of the natural log of tangent inverse. Well, remember the derivative of the natural log is 1 over, so it'd be 1 over x. But we need to evaluate at the inside function, which is tangent inverse of x, and then take it times the derivative of tangent inverse of x, which again, if you look at this table, is just 1 over 1 plus x squared. Okay, and again, maybe you can simplify that. Try to simplify as much as you can, but if not, you might get full credit if you leave it in whatever form you've got. So you can always ask about that in an exam or something. Okay, so that wraps up that particular section. So again, in a way, there's not a whole lot to that. It's a bunch of new derivatives. So we will start to get into some applied things. You might wonder, okay, so we know how to take these derivatives and stuff, but where are we going to use it? We'll start to look at that a little bit more in the next section.